Today we're going to be taking a look at what are called radical binomials. This combines two concepts that we've seen before. First off, radicals that we've been working with, and second off, binomials that we saw at the beginning of the year multiplying binomials when we were looking at polynomials. So first off, a definition. What is a radical binomial? Well, a radical binomial is a number that has both a whole number component as well as a radical. So for instance, right here, this 4 plus the square root of 3, this would be considered a radical binomial. There are two things. We've got our whole number, we've got our radical, and remember, bi means two, and we've got a radical here, so this is a radical binomial. One quick rule that we haven't talked about, when adding or subtracting, not really sure why there was a D there. When adding or subtracting radicals, add and subtract the numbers in front. You don't add or subtract the numbers inside, you only add or subtract the numbers in front. So for instance, 3 square root of 5 plus 8 square root of 5 is equal to 11 square root of 5. You are also only allowed to add or subtract radicals when the numbers inside are the same. If something can be simplified, you need to simplify it as much as possible, but the numbers inside have to be the same in order to add or subtract them. So let's take a look at a couple examples here. These are just real simple examples where I want to multiply whatever's outside of my parentheses times by everything inside. So I'm going to multiply the 4 times by the 3 and the 4 times the square root of 7. So first off, 4 times 3 is equal to 12. And if I multiply 4 times the square root of 7, well, we can't actually multiply the numbers together, but we do stick them together and we get 4 square root of 7. And that would be our answer here. Real simple. Down here with square root of 2, once again we want to multiply these. If I multiply square root of 2 times 5, the 2 is inside, the 5 is outside, so those can't actually multiply. So I'm just going to put them together, so I get 5 square root of 2. And then over here, I can't actually multiply because square root of 2 times by the square root of 2, both those numbers are inside. I multiply them together and I get square root of 4. Just like that. Well, we know we can simplify the square root of 4 because that's equal to 2, so now this becomes 5 square root of 2 minus 2. Now generally we want to write our whole number first and our radical second in any binomial that we have. So for instance up here we had the 12 first and then our radical second. So I need to take this negative 2 and I need to put it on the front. So the negative went with the 2 because we know the 2 is negative, and this is positive 5 root 2, so we get negative 2 plus 5 root 2 for our answer there. Okay, now let's take a look at an example where we multiply a binomial times a binomial. So both of these, we had one thing that we're multiplying times two things. Now we're going to have two things times by two things. Like right here, we've got 2 plus the square root of 5 times by 6 plus the square root of 5. So I want to multiply this the same way that I multiplied binomials before. I'm going to multiply this 2 times both the 6 and the square root of 5, and then I'm going to multiply the square root of 5 times by 6 and the square root of 5. So 2 times 6, first off, that gives us 12. And 2 times the square root of 5 will be 2 square root of 5. So that takes care of my 2, and now I need to multiply the square root of 5 over here. So square root of 5 times by 6 will be 6 square root of 5. And then lastly, square root of 5 times square root of 5 will be square root of 25. First off, we know we can simplify the square root of 25, so that'll just be a regular 5, no more root. And then we can combine like terms. So for instance, 12 plus 5 is equal to 17. And then here, 2 square root of 5 plus 6 square root of 5 will be 8 square root of 5. And this right here will be my answer.